Children, welcome to channel Sube. Today I am going to discuss question number MCQ question number 36 of 2019 Physics new syllabus paper. Consider 4 metal balls of same volume placed on a smooth horizontal surface. Mass of each of the first 3 balls is simple m, while the mass of the fourth ball is 2m. They are equally separated on a straight line. The first ball moves with speed v and collides with the second ball, resulting a series of linear elastic collisions among the balls. After all the collisions, the motion of each ball is best represented by. So there are 5 answers given, velocity diagrams. So we have to find out the velocity of last ball and the first ball, velocity of the first ball and only the velocity of last ball. We don't have to find out the velocities of middle balls. So children, let's try to solve this question. So children, first of all, let's get clear the story of this question, because there are 4 balls colliding. Usually we solve problems with the 2 balls in the classroom. Since there are 4 balls, you might get confused. Therefore, I would like to first of all explain this story, what they say in the question. So there is a horizontal plane on which the balls are placed, frictionless. So these balls, the bigger ball here, the volume cycle, but I mean the mass. So these balls like this on the surface. So let's imagine like this. So what happens? This first ball moves with a velocity v and collide with this second ball, and then what happens? The second ball ejects with a velocity say x, we don't know, and then it collides with this third ball. Then this third ball ejects or moves with a velocity, we don't know, say y, and then it again collides with this ball whose mass is twice. Then definitely this ball must eject to this side, to right, with a certain velocity, we don't know. That is what we have to find out. This one they have given in the answers. So we don't know what happens after colliding with first ball with the second one. Sometimes it might change its direction to this left, or sometimes the value might be decreased or increased, we don't know. Sometimes it might moves to the same direction, we don't know. We have to calculate, we have to find out it. So this first part normally we don't have to calculate in the real-time examination. You must remember it, you must keep it in your heart, and by heart you have to get it. But I will show you that also, because then the students who has not properly understood this lesson, so this video will be more helpful. Therefore, I will show that also. So children, even though there are 4 balls, we consider only 2 balls at one time, because only one ball moves and collide with another. So we consider therefore one collision at one time. So these two balls we consider first, then these 2 balls we consider second, then these 2 balls we consider third. So therefore let's take only this first 2 balls. So this is before the collision. The balls are like this. So after collision, let's draw the balls. these two. So I use colors so that you will not confused, otherwise you will get confused. Therefore I am using colors. So first what happens, they say that this ball moves with a velocity v and this one stationary, so v equals 0. Therefore placed on a smooth horizontal surface, mass of each of the first 3 balls m, while the mass of the 2m, they are equally separated on a straight line. The first ball moves with speed v and collide with the second ball, resulting as they haven't mentioned that, but this ball is at rest, so 0, stationary. So after collision, what happens? The first ball denoted by green color, say its velocity is x. We don't know, it might be increased, it might be greater than v or smaller than v. We don't know, therefore we write x. So we take it as x and then we take this as y. Let's say, assume the velocities are x and y like this. So children, there are 2 types of collisions. One is called elastic collisions, the other is called inelastic collisions. So in this question they have mentioned that this collision is an elastic collision. So there are 2 rules. One is the conservation of momentum, the other is conservation of kinetic energy. The conservation of momentum can be applied to both types of collisions, either elastic or inelastic. We can use conservation of momentum for both, but the conservation of kinetic energy can be used only for elastic collisions. So the question we have been given is in this elastic type collision, we can use this conservation of momentum, and also we can use this conservation of kinetic energy, because it can be applied to this one. Since this can be applied to this both, definitely we can apply to this for this elastic collisions. So we can use these both rules, therefore, to solve this question. What is conservation of momentum? That we use before the collision, the total momentum is equal to final momentum. In brief, that is the conservation of momentum. What is the conservation of kinetic energy? That is, before the collision, the kinetic energy half mu squared of the total objects is equal to the final, after collision, half mv squared, the kinetic energy of the all objects, the total of kinetic energy. So now let's apply this these 2 rules to this system, to this first collision. So I copy it so that you can see it, otherwise. So let us apply linear conservation of momentum for this system. We have to take the momentum before the collision, the total momentum of these 2, and then we are going to equate it to the total final momentum of these 2 bodies. So mv, this one, plus since v equals 0, then m times 0, so 0, then we don't have to write it, equals mx plus my. So we take this side as positive. So here we can mark these arrows because momentum is a vector. The direction of momentum is given by the direction of velocity. So all the velocities are to right side, so therefore all the momentums are to right side. So simplify, m cancel, v equals x plus y. Then we are going to apply the other rule. What is it? Conservation of kinetic energy. The conservation of kinetic energy, not just conservation of energy, kinetic energy. So that is half m, this one, mv squared plus this velocity is 0, therefore no kinetic energy, so 0, you don't have to write it, equals the total kinetic energy after the collision. So separately we write half m x squared plus half m y squared. Do we write arrows here like this, like we did in this previous one? No, because this kinetic energy is not a vector, it is a scalar. It is not a vector. Energy is not a vector. Energy is a only the magnitude we have to get. It is a scalar. So therefore we don't write arrows. So simplify, half cancel, m cancel, half cancel, m cancel, half cancel, m cancel. So v squared equals x squared plus y squared. So we have to now substitute from this equation. Children, what we are going to do is we are going to find the relationship between these three, v, x and y. So let's therefore square this equation. V squared equals x squared plus 2 times xy plus y squared. So we substitute it here, x squared plus 2xy plus y squared, that is v squared, then equals x squared plus y squared. We combined two rules, linear conservation of momentum and conservation of kinetic energy. So x squared cancel, then I write the remaining, what is 2xy plus y squared equals y squared. So all the terms have y, then I can cancel one y from each term, then what is remaining, 2x plus y equals y, then 2x equals y minus y, we take this one here, then 0, 2x equals 0, then x equals 0. That is the result we received. So that means this one come to rest, this one doesn't move, x equals 0. So let's check y, what happens to y. So we take this equation again. So v equals x time x plus y. So we know now x equals 0, therefore 0 plus y, then y equals v. Then what happens after the collision? Before the collision, this one after the collision here, what happens? X equals 0, y equals v. this velocity. So x equals 0. That means this velocity. Green color, this one red color. They have exchanged their velocities. So the theory is that if this masses are equals velocities change. That you should keep in your mind. So actually in the real-time examination we don't do this, we don't calculate all these things. We must know, we should keep it in our mind that if the masses are equal, the velocity change. So what happens when this one come and collide with this this ball whose mass is equal, then the initial velocity to this side now. So this one come to rest and this one get the velocity v. Then this one collide with this third one, the second one collide with the third one, then the third one get the velocity v, the second one come to rest. Like that, finally we have to now calculate this one. So in the real-time examination we don't do this calculation. We should know by practice that the velocity of this first one change to the second one. The first one come to rest. First one come to rest if the masses are equal. So that is the theory about equal masses when they are colliding. So now let us do the calculation for the collision that happens between these two. This is what really we do in the real-time examination. So these two balls, let's copy like this, M and 2m, the balls whose masses are m and 2m. The velocity of this one we know v, because that v came from here, v, and this came to rest, and this one came with the velocity v, and again this one came to rest, became rest, and this one got the velocity v, and finally it collides with this 2m with the velocity v. That is what we have written here. So this one is stationary, velocity 0 at rest. So after collision, say this one take the velocity as x, assume the velocity of this one y. Not previous x and y are entirely different, but just let us take as x and y for our convenience, otherwise don't have to take x2 or y2, then it will be complicated. So let's write the first equation. mv equals mx plus 2m y, because 2m here. Then simplify, v equals x plus 2 times y. Then the other equation, conservation of kinetic energy equation, half mv squared, this one, plus 0, this one, no need 0, equals half m x squared, this one, plus half m 2m y squared. So half cancel, m cancel, v squared x squared plus 2 times y squared. So we take the square of this because we have to substitute to this v squared. So v squared x squared plus 4 xy. Remember 4, not 2. Then 2 times 2, 4 y squared. Because in mathematics we take this as x, we take all this as y. 2 times xy. So 2 times xy means 2 times y, then 4 times. So we substitute it here. Then x squared plus 4xy plus 4y squared. Now this part, x squared plus 2 times y squared. X squared cancel. Then 4 times xy plus 4 times y squared minus this one we take here, 2 times y squared equals 0. Then this 2 times y squared 4 times xy plus 0. Then 2y squared equals minus 4xy. So 1 y cancel. Then 2 times y equals minus 4x. Then y equals y equals 2 times minus 2 times x. Y equals minus 2 times x. So this is not the goal. We have to get the relationship with v, initial v. So let's use this equation again to find the relationship with v. We substitute this y here, x plus 2 times y means minus 2 times x, then x plus minus 2 times 4 times x, then how much? X minus 4x, then minus 3x, minus 3x, then x equals minus v divided by 3. X equals minus v divided by 3. Then again we come here, y equals minus 2 times x, x means this whole thing, then minus minus plus, you don't have to write it, 2v divided by 3. Y equals this value, x equals this value. So the final velocities are these velocities, 2v divided by 3 by x is v divided by 3 minus, that means to left. So this one is correct. So children, this fourth one is the answer. Therefore I think you can understand this. So I did everything clearly, I calculated everything clearly, even the first part that you must have done when you are doing exercises in the classroom. You don't do that in the real-time examination. You just start from here in the real-time examination, not previous calculations you do in the examination. But I showed all those things. So if you are happy, please subscribe my channel. See you tomorrow. Goodbye.